Well, we're going in a different direction here. Today, I'll be presenting some work from deepwater areas in Lake Superior. This might be frightening for some of you, especially if you believe in the zombie apocalypse, but I've toned it down quite a bit. So I'll be reporting some work we did with Siscowets in the deep. I'll talk more about this fish. This is not normal, um, just so you know. So before I move on to talk about Siscowets, let me just talk about the lake trout ecomorphs for those that aren't familiar. In Lake Superior, we have at least four ecomorphs, and the two dominant forms are the lean and the Siscowet lake char. Lean is basically the what we know as lake trout across the Great Lakes. Inhabits waters less than 80 meters. It's demersal pelagic, so it lives off the bottom and goes throughout the water column. It's got intermediate lipid levels. We've measured them from 10 to 50%. And it's the longest lake char form that we have in Lake Superior. Gets over a meter, about 130 centimeters. The most dominant form in Lake Superior is the deepwater form, the Siscowet, which I'll be talking about today. It's also called the fat lake trout for good reason. It inhabits waters from 60 meters out to the maximum extent at just over 400 meters. It's demersal and pelagic, but it does conduct a lot of vertical movements based on some satellite tag work we've done. They forage throughout the water column to maintain their caloric content. Um, they also have really high lipid levels, given its name fat. We've measured lipid levels over 80% in some of the larger adults. And they don't get as long. They get to just about a meter because they're allocating a lot of their energy to body mass and lipid content. So the Lake Superior Technical Committee has conducted deepwater or Siscowet surveys since the mid 1990s, and it's conducted every 3 years. We use benthic gill nets deployed at 20 fathom intervals. So a fathom is 6 feet or 37-meter intervals. And this is done across the lake by agencies if they have the assets to do it in their management areas. So we can basically profile the abundance and looking at population dynamics of Siscowets, but also we look at the abundance ratio with leans, just to look at that mixture of the two ecomorphs. And in addition to the standard biological data we collect in surveys like length, weight, sex, and maturity, we also notate anomalies. In our surveys, we'll notice fish that are emaciated, such as this one on the lower left, the zombie-looking fish, which I'll be talking about further. But we also annotate other anomalies, such as deformed spines or any lesions or tumors that we may notice that could accumulate to a level where it warrants further looks. So in our standard surveys, we do see emaciated or zombie-looking fish every once in a while. A lot of this relates to sea lamprey wounding. So you can see this individual has a wound, but also Siscowets tend to have a lot of lamprey attacks. In recent years, since about 2010 in these surveys, in deeper areas, probably deeper than 180 meters, and I'll show some data for that, we're seeing a higher frequency of these zombie-looking fish, and some are really extreme. And so one thing I want to point out is when we classify them as emaciated, it's just a visual categorization. So there are some individuals that are on their way to being a zombie, and I'm not sure how to gauge that yet. So we're going to look at some analytical methods. But what I have right now is there's enough data to show that there's something going on in the system. So back to this fish. This is a fish that we caught at Superior Maximus, the deepest part in Lake Superior at just over 400 meters. Its length is 553 millimeters, and it's about 730 grams. And its lipid content is 7.5%. Recall I mentioned that this form should have really high body fat content. And this fish was assessed at 20 years old. So what I did is I queried the data for all fish that we caught at this length in our surveys in deep water areas. And the average weight should be 1.2 kilos or higher. So this thing is nearly half the weight. The lipid content should be 25.5 to 30%, and it's a third of that. And it's the same age. So people have been asking whether or not these are much older. They're just senescence, and we're just seeing these things float around and, or I guess not walking around, but in zombie land. And so I'll have some data to kind of summarize what's going on with these, with how many we've collected. So today I'll be presenting data from MI5 and MI6 in South Central Lake Superior in Michigan waters. And these triangles represents our deep water sampling stations. And most of the incidents of these zombies we've been noticing are in this deeper areas over 180 meters, MI6 mostly. So this is just a summary of growth and demographic information from the normal Siscowet versus the zombies. So in the top left, excuse me, is the percent lipid we measure in Siscowet. So typically they should be over 40% on average. So this horizontal bar represents the median value. You can see in the zombies, it's way below that, and it's pretty obvious when we look at these pictures. And this is for the same size, so there's no difference in sizes in what we're sampling between the zombies and the normal Siscowets. And also age structure is very similar. And on the lower right represents the weight distribution of the normal Siscowets versus zombies, and we can see they're much lower. There is a lot of variability with weight in the fish. But the other thing to note is that I'm also visually classifying these emaciated, so there's probably a whole group of them on their trajectory to becoming a zombie status. And so you'll see some degree of error in that judgment call in the future slides. So over time, we've noticed that the incidence of these emaciated or zombie fish has been increasing. The y-axis here represents the proportion of what I call emaciated Siscowets, and the x-axis represents those depth zones, those 20 fathom depth zones. And each individual bar represents an annual measure of the percent emaciated or proportion emaciated. And the key thing to note is that in deeper areas over 180 meters, we're seeing that the bar is getting higher, so more recent. One thing I want to point out is in this area, we're also measuring declines in Siscowet abundance and also recruitment that's going on with this. This is a series of plots looking at the relationship between a given weight and length for individual Siscowets by depth zone. So these are those 20 fathom intervals, each of these boxes, and the weight is on the y-axis. So these little individual dots represents an individual fish's length and weight. And then we could do a model fit through them to look at what we think is like a normal growth function, which is that solid line for the population. And then these dashed lines represents percentiles. So it's kind of like your kids at school, you know, what height they are and things like that. So looking at the lower line below, that's the 25% line. That's where we see weight below what we think is should be observing in the population. And the fish that I flagged as emaciated are shown in the yellow dots. And so you can see there's a higher frequency of these yellow dots in deeper areas starting at 180 meters, and especially in the deep zones, we see a lot of them down here. And these are data from since 2000. So we are seeing that it's a more of a depth-related effect, and these conditional anomalies we're seeing with the zombies. This is another way to look at it. From those weight-length relationships, we're able to kind of standardize it by looking at the weight of a given size. So the top two panels represents the weight we should expect for juvenile fish. So on the top left is 400 millimeter Siscowets. On the right is for 450 millimeters. And then for adults, it's 600 and 700 millimeter fish on the bottom. And what I did is I consolidated the depth zones into three zones: shallow, intermediate, and deep. And then these individual bars represents that expected weight for that year at that size. And what we're noticing is for small fish, we're noticing it in really deep areas, but for larger fish and adults, we're noticing it in, again, the same depth zones, intermediate and deep areas, and it is declining over time. So what we're seeing is changes in the population of Siscowets in deep areas in terms of condition corresponding to changes in declines in abundance and recruitment. And these extremely skinny zombie-looking fish, there could be a lot of hypotheses. I think the simplest thing is to look at an ecological explanation, which would be food limitation. The food web out in deep water areas is very delicate and simple, kind of like the Arctic. It doesn't take much to destabilize nutritional content for these animals. If one species of prey fish declines, it could really put them into a competitive event and create these type of events. Another hypothesis could be a disease that's causing this. This spring, we have fish health folks from MSU coming out with us to assess these, to do a fish health assessment to make sure there's nothing pathological that's going on. Another hypothesis would be related to sea lamprey parasitism. So there are sublethal effects. We preliminarily look at the data. The wounding rates between zombies and the normal Siscowets appears to be the same, but there are different categories of wounding, and then the healing of lamprey wounds on Siscowets is a lot different than leans. So that could be an explanation, that there could be some sort of effect from sea lampreys. That it takes a deeper dive into looking at that. Another thing it could be is contaminants, and I'll talk about that in the next slide. There could be some sort of contaminant out there that could be causing some of these individuals to get into that condition. And it could be some sequence of these relationships: disease creating food, starvation, or starvation creating increases in disease. So there could be some sort of combined effect. So this is just preliminary look at this. As I mentioned, we have a fish health assessment group coming out in June to kind of sample these and see what's going on, if there's any disease issues. I'm going to coordinate with other agencies that may be seeing similar data. Nicole Watson mentioned that she's been trawling up some zombies in deepwater areas. So I need to sit down with her and other agencies to see if they're observing this in deepwater areas in other parts of the lake. Related to that, I'd like to take a finer look at prey fish abundance in deep water areas to see if there's any changes that correspond to what we're seeing out in deep water areas with Siscowet populations. And then, as I mentioned, I want to take a closer look at sea lamprey wounding rates in terms of the different categories, and look at these between the two groups, the zombies and the normal fish. Dr. Gord Patterson at Michigan Tech University actually has taken some of these zombies and normal Siscowets from the deep areas and has been looking at mercury levels. He had a hypothesis that they would be pretty concentrated on these zombie fish. And so he has a grad student working on that. And this is just preliminary data looking at mercury levels. There's three groups of Siscowets here. The Isle Royal Siscowets on the far left are below dangerous levels. So anything that shows up in that yellow rectangle are EPA, FDA consumption advisory levels as choices to avoid, to consume. And you can see the Siscowet at superior maximus, the normal Siscowets, are actually elevated into mercury, and they're much higher in the zombie fish here on the right. So the student's working on a lot on those fish right now to get more examination of the other tissues. And with that, I'd be glad to answer any questions. Hopefully we caught up.